So that's pretty cool, right? We've got some trend lines on an awesome graph. But it also raises another question. And that question is, why is there variation? Let's see, how do I word this? Between power plants with the same power output. Why isn't every plant that generates 100 megawatt hours of power emitting the same amount of CO2? Like why isn't every coal plant emitting the same amount of CO2 for a specific power output? That's a little weird, right? Like you'd think you're burning coal, it should have about the same CO2. So why doesn't every single data point lie on that line? Let's go ahead and investigate that. To do that, we need to use some calculated fields in Tableau. Let's go ahead and name this worksheet first. I'm going to rename this sheet plant generation trends. Okay, so let me back up for a second. In order to answer this question, shoot, my voice. In order to answer this question, we'll need to generate two new measures. We need two new fields that we need to calculate. One of the fields that we need to calculate is a measure of CO2 intensity. So I want to know per megawatt hour, how much CO2 is generated for all of these plants. We'll call that CO2 intensity. So CO2 emissions divided by megawatt hours. The second measure that I want to create is power plant efficiency. If a power plant is super inefficient, then it probably generates more CO2 than a super efficient power plant. So we'll need CO2 intensity and power plant efficiency. And when we graph those, we might figure out some of this variation. So we'll do that next. So in order to do that, we need to create some calculated fields. And to create a calculated field, I'm going to go up to Analysis, scroll down to the bottom where it says Create Calculated Field, and I will create a calculated field. The first calculated field that I want to create is CO2 intensity. And the way that you type in calculations like this is actually very similar to Excel. So if you were to do a calculation in Excel, it's pretty similar. So CO2 intensity, we said, was CO2 emissions divided by megawatt hours. So I'm going to type in bracket reported CO2e emissions. And once you start typing, the variables pop up. So I'm just going to grab this reported CO2 emissions. And I'm going to divide that by bracket net generation megawatt hours. And I'll click OK to create that calculated field. Okay, now I need to create a second calculated field to figure out power plant efficiency. And you'll note on measures we have, under power plant generation, we have net generation in megawatt hours, and we have fuel consumption. So a power plant, man, I'm dying. A power plant efficiency is a ratio of the energy output divided by the energy input. So if you put in 100 units of energy and the power plant generates 80 units of energy, then that power plant is 80% efficient. Does everyone follow that? So what we'll need to do is divide this net generation by fuel consumption to figure out the power plant efficiency. And we'll do that next. I'm going to go up to analysis again and create a new calculated field. And I'm going to call this plant efficiency. Now, the calculation for this isn't quite as straightforward because they are not in the same units. So we need to add in a unit converter there. So fuel consumption is in units of MMBTUs, which is a unit of energy, and net generation is in megawatt hours, which is a unit of electrical energy. It's a little bit different. But ultimately, we still want to do output divided by input. So I want to do parentheses, bracket, net generation, times our unit conversion, which in this case is 3.412. So a megawatt hour times 3.412 is 1 MMBTU. I'm going to close my parentheses there and then divide by our fuel consumption, electric fuel consumption. So everyone have that and calculation is valid? Okay, I'm going to hit OK.
What symbol did you use for times?
Asterisk. Yeah. Same as Excel. Okay, and I'm going to create a new worksheet where we will play with those two calculated fields. And before I start dragging things onto the rows and columns, I'm first going to filter out all of the power plants that we don't care about, just so that the graph is a little more clear. So I'm going to first drag AER fuel type code onto the filters, and I want to include only coal, fuel oil, and natural gas. I'll hit OK. Okay, so now we are ready to start setting up this graph. I'm going to click and drag plant efficiency onto columns. And I'll click and drag and put CO2 intensity onto rows. Again, we have a single data point because I haven't told Tableau what level of detail I want this graph to be. So I'm going to grab the plant name and drag that onto detail. I will also drag fuel type onto color. So AER fuel type onto color. Okay, so this graph looks awful. This is not at all what I expected. I was hoping for a nice graph with nice trends, and it would be clear and we would instantly see what's going on. But it looks like we're running into issues. So we might be running into issues in one of two places. Either the calculated fields that we set up are super screwed up, or the underlying data set has errors in it. Now, the calculated fields that we built are really, really simple, so I doubt that that's the issue, which means that the problem is with the underlying data set. So there's probably errors somewhere in the underlying data set. If this were an actual research project, I would absolutely go back into the data and look at that and try and figure that out. But for now, let's just filter out all the crappy data. So one thing that we know about efficiency is that it can never be negative and it can never be above 1. You can never get more energy out of a system than you put into it, and you can never get negative energy out of a power plant. That just, no one would build that. Why would you do that? So I'm going to drag plant efficiency onto filters. And this dialog box pops up because it's asking, how do we want to filter this measure? And I want to filter every single value. So I'm going to click on all values. I will click next. And now we have this number line. Again, I only want plant efficiencies between 0 and 1. So I'm going to adjust this to be between 0 and 1. And I'm going to click OK. So that gives us all of the valid plant efficiencies that's been calculated within this data set. Does everyone have that? One of the other things that I want to do just to be safe about this data is I'm going to change the sums to averages, just in case that a plant is duplicated somewhere in the data set. I don't want, so if there was a duplicate plant ID in the data set, if we were to sum it, it would double count. But if we do average, then it'll just take the average of 2 identical entries, which is the single value that we want. So I'm going to change these sums to averages. Does that make sense? Okay. I'll change these sums to averages. The next thing that I'm going to do is get rid of these 3 null values because that box is bugging me. And I'm just going to filter these out. So I'm going to click on those 3 nulls and I'm going to filter that out. Now looking at this graph, it looks like we might have valid data way at the bottom here, but there's a few ridiculous outliers on CO2 intensity. So I'm going to drag CO2 intensity onto filters, and I'm going to filter based on that. Again, I want to filter all values. And the lower limit of 0 is fine. And just because I've done this before, I know that a reasonable upper limit is 3. I'm going to write in 3. Quite a difference from 27,000. Okay, so now we're finally at an interesting picture, and this makes a lot of sense. So what do you guys see in this picture? What is this telling you?
That most plants are similar in efficiency and there's a few outliers.
Yeah, so that's one takeaway. If I'm looking specifically at coal, the blue dots, all of the coal power plants are around 33–34% efficient. And most of them are within the same CO2 intensity, but there are some outliers that just are probably terrible at burning terrible coal. If we look at just the natural gas, it looks like there's kind of a 1/x trend line. So it looks like it's, as the natural gas power plants get more efficient, the CO2 intensity drops, which makes sense. That's what we would expect. But there is some sort of like lower limit here. So that's pretty interesting. So it turns out that no power plant can operate at 100% efficiency. In fact, no power plant can operate above 80% efficiency. It's thermodynamically impossible. And also, the most profitable efficiency for a power plant to operate at is right around 34 to 40%. Just because if a plant were to be more efficient, it would be more expensive to build the capital equipment that is more efficient. So there's some really cool thermodynamic properties in there, and that's just me on a tangent geeking out about what I geek out about. But 34% is there's a very specific reason why that's the coal power plant's optimal efficiency. So this is a really cool graph, and we generated that through 2 calculated fields, and we calculated those fields from 2 completely different data sets from 2 different organizations, and we were able to combine it all together into a single graph, and I think that's really cool. You can just imagine if you tried to do this graph in Excel, it would be an absolute nightmare to organize the data in a way that makes it accessible. Even in R, it would be kind of difficult to do. So we did it in maybe 10 minutes. Okay, so at this point, I've gone through everything that I want to go through for specific charts. And the next thing that I want to hit on is dashboards. So how do we generate those dashboards? If you remember at the very start of the thing, we saw a dashboard with a map and then some graphs underneath, and we'll build something out very similar to that. Before we move on, I'm going to rename the sheet and I will name it efficiency trends.